Electromagnetic interference, or EMI, occurs when electromagnetic fields generated by nearby electrical equipment induce electrical currents within a bearing system. Unlike electrostatic discharge, which involves sudden high-energy static discharges, EMI produces continuous or repetitive low-level electrical currents that pass through the rolling elements and raceways during normal operation. These induced currents do not create explosive discharge craters. Instead, they cause electrical erosion, where metal is gradually removed at contact points. Over time, this results in fluting, characterized by evenly spaced washboard-like grooves along the raceways, surface frosting, visible accumulation of fine particles or debris on bearing surfaces, and fine micropitting, small, rounded depressions holes on rolling elements and races. EMI damage disrupts surface metallurgy, degrades lubricant films, and accelerates oxidation. The fine debris generated by electrical erosion circulates within the bearing, increasing friction, vibration, and audible noise. As exposure continues, localized wear patterns evolve into widespread fluting, leading to premature bearing failure. Unlike ESD, which is intermittent and driven by static charge buildup, EMI damage is continuous and operational, often originating from variable frequency drives, high-frequency switching, poorly shielded cables, grounding imbalances, or electromagnetic coupling from adjacent equipment. Without proper grounding, shielding, and current diversion, EMI-induced currents persist, steadily eroding bearing surfaces